Here's the video for Thursday's homework for the 4 short answer questions, 25, 26, 33, and 34. So question 25 says the table below shows the number of hours of daylight on the first day of each month in Rochester, New York. Given the data, what is the average rate of change in hours of daylight per month from January 1st to April 1st? Average rate of change, we should recognize, means slope. We're going to be taking the change in y's over the change in x. And our x's are coming from the 2 months listed. So January and April. January is month number 1. April is month number 4. So we have the 0.1, 9.4. That could be our x1, y1. And the 0.4, 13.9. That could be our x2, y2. So plugging in, we get 13.9 minus 9.4 all over 4 minus 1. You could either simplify in pieces, or you could do it in your calculator, hit the fraction button, alpha y equals choice 1, and type it in all at once. If you're doing it in pieces, you get 4.5 over 3, and everyone in the end should get 1.5 as their average rate of change. Second part to the question, interpret what this means in the context of the problem. This is the third one we have done in the last week and a half that has done this with our slope formula, where it wants you to interpret it afterwards. This means that between January 1st and April 1st, the 2 months that we used, the average hours of daylight will increase by 1.5 hours per month. It's happening each month. You can see in the table 2 that we went from 9.4 up to 13.9. So that's another reason why it's increasing. Anything along those lines with that description would work for this question. Second question, we've seen this quite a bit as multiple choice, where I tell you that you can just plug the answer choices in to see what works and what does not work. So here is one where it's now short answer, and we definitely have to know how to do it by hand. We don't have answers that we can just plug in. Algebraically means that you do have to solve it by hand. So whenever you're dealing with fractions being added or subtracted, we have to think of a common denominator. The binomial x plus 1 is the only binomial there, so it's definitely coming down into my common denominator. I have a single x sitting there that has to come down. And then 2 and 4, if you want, you can make it an 8, which will just be a little more simplifying. But 2 and 4 both go into 4, so our common denominator should be 4x times x plus 1. So now we want to make everything match. So for the 2x, I need to multiply 2 times 2 to make it a 4. And then it needs the binomial, the x plus 1. If I'm going to multiply this into the bottom, I am also going to multiply it into the top. So 7 times 2 is 14 times x plus 1. Second fraction has the x plus 1. It needs the full 4x. So it needs the full 4x. Again, whatever I do to the bottom, I'm going to do to the top. So the full 4x goes on top. So now we're doing minus 2 times 4x is 8x. And it's going to equal, the last fraction has the 4. It needs the x and the x plus 1. So that means the top as well needs the x and the x plus 1. 1 times x is just x, and we're still going to multiply it by x plus 1. Now that the denominators were all the same, they did cancel, which is why I did not continue writing with them. So now solving this equation, first thing I'm going to do is distribute 14x plus 14 minus 8x equals x squared plus 1x. Combining like terms on the left, I get 6x plus 14 equals x squared plus 1x. If you're dealing with a squared and solving an equation, we set it equal to 0. So I'm going to subtract the 6x over and subtract the 14. So I get 0 equals x squared minus 5x minus 14. I now have a trinomial without a leading coefficient, so I can do my basic AM method. I need to find two numbers that add to -5, multiply to -14. I get x minus 7, x plus 2. I can then set each one of those equal to 0 to get a positive 7 and a -2 as an answer. You just want to make sure that neither of those values make any of the original fractions undefined. In this case, they don't. If it was undefined, they would give you a 0 in the denominator. So the first denominator was 2x. If I plug 7 in, 2 times 7 is 14, not 0. Second denominator, x plus 1. If I plug in 7, 7 plus 1 is 8, not a 0, so 7 is good. And same thing with the -2. One denominator would be -4, one would be -1. As long as they're not 0, they're okay. Question 33. Factor completely over the set of integers. So taking a look at this, there's no GCF to pull out. That should always be our first step of factoring. They don't have anything in common. So next, adding up, there's two terms. Everything is a perfect square, which makes this dots, the difference of two squares. So double parentheses, 16x to the 4th breaks up as 4x squared and 4x squared. 81 is 9 and 9. And then one gets a plus, one gets a minus. It does say to factor completely, in which case we're still not done because the last parenthesis is dots again. The first one is not dots because D stands for difference, which means subtraction, and that first parenthesis is addition, not subtraction. So the first parenthesis, 4x squared plus 9, comes down. The 4x squared minus 9 breaks up as 2x plus 3 and 2x minus 3. There is our final answer for the first part. Second part says Sarah graphed the polynomial y equals 16x to the 4th minus 81, so the one we just factored, and stated all of the roots are real. Is Sarah correct? Explain your reasoning. So different ways to go about doing this. One way is to use your calculator and look at the graph the same way Sarah did. In order to do that, you do have to know how many roots there are supposed to be. So this is y equals 16x to the fourth minus 81 is degree 4, which means there should be 4 roots. This is not the first question that we've had where we're talking about roots being real or on the opposite, imaginary. If they are real, they all become x-intercepts. So that means that if this is a degree 4 and there are 4 roots, if they are all real, there should be 4 x-intercepts. So if we go to graph this on our calculator, go to y equals, type in 16x to the fourth minus 81, and look at the graph. We may have to zoom out a little bit. You can adjust your window if you want. Sometimes zoom fit, which is choice 0. Sometimes that helps you. Although this one, it didn't really help, but I could see that we went up to 30,000. So if I adjust my window, my Y max down. Let's see if that helps. Still not better. So let's go smaller. Still not helping. So there I went to negative 1,000 and positive 1,000 for my Y's. It looks like you go probably even smaller. But here I only have 2 x-intercepts. So according to this, if it was degree 4, there are 4 roots. However, only 2 x-intercepts. So however, there are only 2 x-intercepts. So not all roots are real. Another option, your roots are also called zeros. If you take the factors that you came up with in the first part and set them equal to 0, those are your zeros, which then we can see if they become x-intercepts, if they are real or not. So the 4x squared plus 9, when I go to set it equal to 0, since that one was no longer factorable, I would have to subtract the 9 over, divide by 4. If you go to take the square root and plug this into your calculator, you remember to put the plus minus, and your calculator will give you 3/2 I or 1.5 I. So right there, it goes to show that they are not all real. So 2 different options for that question. Either one works. You can use the graph, or you can actually use your factors and continue solving. Last question from the homework. It says the half-life of a radioactive substance is 15 years. Write an equation that can be used to determine the amount, S of t, of 200 grams of this substance that remains after t years. So half-life means that we are decreasing our amount, and we're decreasing by 1/2 or 50%. And we're doing that every 15 years. So if we are decreasing by 50%, we are dealing with our decay formula. Instead of A, they want us to use S of t. P, the initial amount, is 200. R is the 50%, which is 0.5. And if you notice right there, 1 minus 0.5 is 0.5 or 1/2. So that's another way you could do the half-life. Just know that it's automatically a 0.5 in there. Only thing that we have to be careful with is this is saying it's happening every 15 years, not every year. If you think back to when we did this unit, the word every meant that you are dividing your exponent by the number that comes after. So t is being divided by 15. Second part, determine algebraically to the nearest year how long it will take for 1/10 of this substance to remain. So if 1/10 of the substance is going to remain, we're starting off with 200 grams. So 1/10 of 200, you can multiply, is 20. 1/10 of 200 means that 20 grams remain. So we can plug this in for S of t, which is the final amount, and solve our equation for t, which we've done quite a few of over the last week and a half. Now, even if you were stuck on the first part and didn't know fully how to write an equation, in order to get partial credit, you could just come up with a random formula, and then attempt to solve it for the second part to get some partial credit so it shows that you knew how to do the second part. So solving for your exponent, we always divide the initial amount over. 20 divided by 200 is 0.1. And we have 0.5 to the t over 15. 0.5 is my base. T over 15 is my exponent. It equals my A answer, which is 0.1. And we are going to rewrite this as log B. So log of 0.5 of 0.1 equals t over 15. Plug this into your calculator. Alpha window choice 5 gets you the log with the base. We get 3.321928,095 equals t over 15. And this one has one extra step. T is currently being divided by 15. So I want to multiply the 15 to the other side. And we get 49.82892,142. And they said to the nearest year. So rounding to the nearest whole number, we should get 50.